Good morning, welcome back. Alright, we're going to jump right on into it. Here is where we are going. I'm going to do number 1 as an example. You're going to do 2, 3, 4 for practice, because you can. And once you get the hang of this is really not so bad. Off we go. So we're going to do some weird things to some balloons over the next few days. Trap samples of gas. Temperature in my fridge, I'm going to put this balloon in a fridge, is 4 degrees Celsius. If I place a balloon in my fridge that initially had a temperature of 22 degrees Celsius and initially had a volume of 0.5 liters, what will be the volume of the balloon when it's fully cooled in the fridge? That was a lot of words. And it was 3 numbers. Okay, here we go. Okay, we are going to do these in 3 steps. Step 1 is sometimes the trickiest step. Step 1, we want to figure out the initial or the start conditions and also the end conditions. Okay, I'm going to zoom a little bit. So we want to figure out the initial conditions and the end conditions. That is step 1. Here we go. Temperature inside my fridge is 4 degrees Celsius. If I place a balloon in my fridge that initially has a temperature of 22 degrees Celsius, so you have to figure out, you're given these 2 temperatures, which is your start temperature and which is your end temperature. So there is your key word. We initially have a temperature of 22 degrees Celsius. So in your initial spot, your start spot, your initial temperature, this is how you're going to set it up. You're going to say it's a temperature, T, equals your initial temperature is 22 degrees Celsius. My volume, blah, blah, blah. What will be, in the end, what will be the volume? Yeah, we could, let's do temperature first, then volume. The end temperature, when it's fully cooled in the fridge, is the temperature of your fridge. So your end temperature is 4 degrees Celsius. And let's do, okay, so there's our temperatures. We just figured out our temperatures. And the volume initially has a temperature of 22 degrees Celsius and initially has a volume of 0.5 liters. We're going to take that initial volume, V for volume, we're in the initial spot over here, so the start spot, the start volume, initial volume of 0.5 liters. Okay. Do you need to do the setup? Yes. Yes, you do. You need to do the setup every single time. If this seems massively easy, fly through it. If this is the hardest step of the whole thing, you are not alone. And this will drive your boat. This will get you where you're going. This is the only way you're going to get where you're going. Okay, we've got 2 temperatures, we've got 2 volumes. What will be the volume when it is fully cooled in the fridge? So in this end state in the fridge, where the temperature is 4 degrees Celsius, question says, what will be the volume? That's our question mark. All right. Feel free to rewind this a billion times and look at that setup. That can be the trickiest part. Cool. But once we're there, we do a unit check. Do we have temperature in the units that we want? No. No, we don't. Okay, so we're going to take your degrees Celsius, add 273, add 273. You're going to get 295 Kelvin as your temperature on your counter. That makes sense. That's about room temperature. You're going to get 277 Kelvin as your temperature in your fridge. That also makes sense. Okay, got your temperature in kelvins. That's what we wanted. We've also got some volume, V for volume. We want volume in liters. Do we have volume in liters? Yeah, we're set. Okay, that is step one. Whew, okay. Step two, the equation step. We're still solving for that question mark. All right, we're comparing temperature and volume. And we are back to this variables relationship page, all those arrows and stuff. Look for your math spot that compares volume and temperature. V over T, they are direct relationship, so V over T will stay constant. What this is going to look like here, your starting volume divided by your starting temperature is going to stay constant even when we change those conditions. That ratio will equal your ending volume divided by your ending temperature. And that is the equation that you will use for everything on this page. In this case, we dropped the temperature, we're going to drop the volume. We're going to make a prediction. We dropped our temperature, we predict that our volume will also decrease. All right. Go and plug your numbers in. Every number gets a unit, just like every other time your whole lives. You're starting, that little one means starting, your starting volume. Pull from your setup, your starting volume is 0.5 liters. Your starting temperature, take your Kelvin number, is 295 Kelvin. V2 and T2, these are your ending conditions here. So your V2, your ending volume, that's your question mark. You could use X, totally. Divided by your ending temperature. You can math your equation here also, by the way, I forgot to say that. You're solving for V2, that's your question mark. You can write this, you can multiply both sides by T2 and get V2 equals V1 T2 over T1. What did I just do there? I just algebra'd the equation. We just moved T2 out of this denominator into this numerator. You can do it that way also, which gets you solving for what you actually want all by itself already. So the starting volume times the ending temperature divided by the starting temperature. These are the same thing. They will both work. Take your calculator. Do I have my calculator? Kinda. You're gonna beat me to this because I don't have a calculator. In your very final step, once you're all set up, find your calculator. And you're multiplying across, multiplying across the top. 0.5 times 277. And then divide by the stuff on the bottom. So click divide, 295. And it worked. Our volume decreased. Our ending volume 0.469. That's too many sig figs. But keep some. Check your units. You're solving for volume. So you're going to predict you're going to be in liters. Okay, but check it. Okay. We've got Kelvin on the top and the bottom. We've got liters left over on the top. That unit is liters. Okay. I'm going to make a brash prediction that you may be back to ask questions, which is totally fine. Yeah, we'll meet again at 9. We can do any questions then. If you have more questions later, email or show up tomorrow or whatever you need to do. You're going to try 2, 3, and 4. Do them exactly the same way. Charles' law means you're comparing volume and temperature. So that equation will work for you all the time on this page. Good. There's pressure too, right? Where's the pressure? We'll do that tomorrow. But yeah, good luck. I think you got it. I'll do all the answers tomorrow like usual. See you soon.